Hey, welcome back. Today we are talking about the Earth's atmosphere. Earth's atmosphere is composed of about 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% other gases. Trace amounts of carbon dioxide, methane, water vapor, and neon are some of the other gases that make up the remaining 0.1%. The atmosphere deals with a lot of our doings. By the way, hurricanes. Hurricanes, or typhoons, is what we call in my country. Hurricanes are caused by the Coriolis force. Listen to Dr. Neil deGrasse Tyson explain it better than me.
So, first of all, these storms are, when we have storms, it's in our atmosphere, so that's gas.
Yeah.
We rotate once a day, and so that rotation creates what we call a Coriolis force, which moving air that moves from one latitude to another, actually has its direction deflected because of this Coriolis force, and this is why storms rotate in one direction counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Just a quick aside, I was channel surfing one day, waiting for a movie to come on at the top of the hour. I had 15 minutes. I hit a football game, and they just ended the game at a tie, and they just started overtime. I said, that's about right. Let me just watch this. How bad could it be? After the necessary exchange of possession, it became sudden death overtime. And then one of the teams, Cincinnati Bengals, got within 50 yards and they kicked a field goal. And the ball rotated up. It hit the left upright of the goalpost and went in. And I said, ooh, wait a minute. And I said, which stadium is this? What's the latitude? And I looked at the orientation of the stadium, I did a calculation, and then I tweeted. And I said, the overtime winning field goal by the Cincinnati Bengals was likely aided by a 1/3 of an inch deflection to the right, imparted by Earth's rotation. People lost their minds. People, oh my! If you were going north-south at all in the northern hemisphere, you will deflect to the right, no matter what you're doing. Okay? That's why you have a low pressure system, and I'm a ball of gas below it. If it's low pressure there and I'm air, I'm going to head for the low pressure. That's how this works. It's low pressure. That means there's higher pressure out here. So all the pressure is going to send me in that direction. But I'm crossing lines of latitude. And so Earth's rotation will deflect me to the right. How about air that's above it? It says, I see a low pressure system. Let me go to it. So it goes to it and it deflects to the right. So all this air deflects to the right, but it's still trying to get to the center of the low pressure system, but it can't because it keeps getting deflected. And all this deflection becomes this cyclonic energy that turns into a storm. And that is how you get hurricanes, tornadoes, cyclones.
Coriolis forces are caused by the spin of the Earth. The faster the spin of the planet, the stronger the Coriolis forces are. For example, Jupiter. But can a hurricane end? I mean, when a hurricane ends, it no longer spins or resembles a hurricane or a spinning eclipse. But that small vortex of wind can pass the Pacific Ocean and be resurrected by the Coriolis force. That's all of the Coriolis and hurricane stuff. Let's move on to the thing about the atmosphere. The atmosphere is so thin compared to the Earth. The skin of an apple is to an apple as the atmosphere of the Earth is to Earth. Mind-blowing, isn't it? The atmosphere can be divided into layers based on its temperature, as shown in the figure below. These layers are the troposphere, the stratosphere, the mesosphere and the thermosphere. A further region, beginning about 500 kilometers above the Earth's surface, is called the exosphere. The troposphere, this is the lowest part of the atmosphere, the part we live in. It contains most of our weather, clouds, rain, snow. In this part of the atmosphere, the temperature gets colder as the distance above the Earth increases, by about 6.5 degrees Celsius per kilometer. The actual change of temperature with height varies from day to day, depending on the weather. The troposphere contains about 75% of all of the air in the atmosphere, and almost all of the water vapor, which forms clouds and rain. The decrease in temperature with height is a result of the decreasing pressure. If a parcel of air moves upwards, it expands. Because of the lower pressure, when air expands, it cools. So air higher up is cooler than air lower down. The lowest part of the troposphere is called the boundary layer. This is where the air motion is determined by the properties of the Earth's surface. Turbulence is generated as the wind blows over the Earth's surface, and by thermals rising from the land as it is heated by the sun. This turbulence redistributes heat and moisture within the boundary layer, as well as pollutants and other constituents of the atmosphere. The top of the troposphere is called the tropopause. This is lowest at the poles, where it is about 7-10 kilometers above the Earth's surface. It is highest, about 17-18 kilometers near the equator. The stratosphere, this extends upwards from the tropopause to about 50 kilometers. It contains much of the ozone in the atmosphere. The increase in temperature with height occurs because of absorption of ultraviolet, UV radiation from the sun by this ozone. Temperatures in the stratosphere are highest over the summer pole, and lowest over the winter pole. By absorbing dangerous UV radiation, the ozone in the stratosphere protects us from skin cancer and other health damage. However, chemicals, called CFCs or freons, and halons, which were once used in refrigerators, spray cans and fire extinguishers have reduced the amount of ozone in the stratosphere, particularly at polar latitudes, leading to the so-called Antarctic ozone hole. Now humans have stopped making most of the harmful CFCs. We expect the ozone hole will eventually recover over the 21st century, but this is a slow process. The mesosphere, the region above the stratosphere, is called the mesosphere. Here the temperature again decreases with height, reaching a minimum of about -90 degrees Celsius at the mesopause. The thermosphere and ionosphere. The thermosphere lies above the mesopause, and is a region in which temperatures again increase with height. This temperature increase is caused by the absorption of energetic ultraviolet and X-ray radiation from the sun. The region of the atmosphere above about 80 kilometers is also called the ionosphere, since the energetic solar radiation knocks electrons off molecules and atoms, turning them into ions with a positive charge. The temperature of the thermosphere varies between night and day and between the seasons, as do the numbers of ions and electrons which are present. The ionosphere reflects and absorbs radio waves, allowing us to receive shortwave radio broadcasts in New Zealand from other parts of the world. The exosphere, the region above about 500 kilometers, is called the exosphere. It contains mainly oxygen and hydrogen atoms, but there are so few of them that they rarely collide. They follow ballistic trajectories under the influence of gravity, and some of them escape right out into space. The magnetosphere, the Earth behaves like a huge magnet. It traps electrons, negative charge, and protons, positive, concentrating them in two bands about 3,000 and 16,000 kilometers above the globe, the Van Allen radiation belts. This outer region surrounding the Earth, where charged particles spiral along the magnetic field lines, is called the magnetosphere. And still it's a small world we live in. And as always, thanks for, wait a minute, wrong outro. And as always, bye Earthmates.